Brace for impact!
Found now that another vessel has sunk with all crew lost.
At the southern tip of South America, ships hit a stretch of ocean that feels wrong. Down there, modern steel ships can snap like toys. Windows can explode from a single wave, and storms don't pass through. They are born right there. Sailors have feared this water for centuries, and captains still plan entire routes just to avoid it. This is the one place on Earth where the ocean doesn't just get wild. It breaks the laws of physics. The ship graveyard between South America and Antarctica. The trouble starts the second a ship clears the last bit of shelter near Cape Horn and points its bow into the open gap between South America and Antarctica. The sea that looked rough a moment ago suddenly turns mean. The swell stretches out, then stands up steeper. The whole hull shudders like it's being grabbed and shaken. Cupboards slam, plates slide, and the horizon keeps getting erased behind walls of gray water. This is the Drake Passage, the 500-mile-wide stretch of ocean between the very southern tip of South America and the first islands off Antarctica, linking the South Pacific to the South Atlantic.
And there's a lot of ships that have sunk around that area. It's got major storms and major different weather patterns. And so it was really stormy before we even left the dock.
To an old-school sailor, this wasn't just bad weather. This was the edge of the world. Behind you sits Cape Horn and the last known coastline. Ahead is nothing but wild sea and ice, and there is no other easy way across. To the west lie thousands of miles of empty Pacific. To the east lies the long hook of the Atlantic. Down here, at this single gate at the bottom of the map, everything gets forced through one narrow gap. Part of the trap is how the planet is built. Between about 40 degrees south and 60 degrees south, there is almost no land to slow the wind or break the waves. In these latitudes, strong westerly winds can run almost all the way around the globe without hitting a continent. So they just keep feeding the sea over and over, stacking power into the water again and again.
My engine has lost power. We are 100 meters from rocks.
On a flat map, it looks like empty blue. Wrap that map around a globe and the shape jumps out, a ring of water circling the planet, with South America and the tip of the Antarctic Peninsula reaching toward each other like two fingers. Between those two bits of land sits the Drake Passage, the narrowest gap in that ring. In calm weather, it's a shortcut. Most days it feels like a trap, and the fight isn't only in the water, it's in the air above it. Over Antarctica, a huge dome of very cold, very heavy air forms and slowly slides downhill off the ice sheet. To the north, over the open ocean, the air is a little warmer and wetter. Right over the general area of the Drake Passage and the nearby seas, those two air masses crash into each other, and that clash keeps spinning up big, swirling storms that drive so much of the Southern Ocean weather. For ships, that means this place isn't calm with the occasional storm rolling through. Storms are made here, again and again. Wind over the Drake Passage can easily blow above 60 miles per hour and in rougher spells gust over 80. In that kind of wind, the tops of the waves get ripped off and turned into long sheets of spray. From the bridge, the world can turn white. Crews call it sea level whiteout, when air and water blend into one moving wall, and you can barely pick out the bow of your own ship. In winter, or even in cold parts of summer, that spray becomes dangerous. Every drop that hits metal, rails, antennas, deck fittings, freezes the moment it lands and builds up into thick, heavy ice. Icing is one of the quiet killers down here. The air is just below freezing, the sea a little above, and the ship is trapped between them. Every burst of spray adds another thin layer. Over a few hours, that can grow into several tons of ice glued to masts and superstructure. Weight climbs higher and higher on the ship's body. The whole vessel becomes top-heavy and starts to roll more. The only way to stop it is often the most dangerous job on board, sending crew out with hammers and crowbars to smash the ice off while the deck rises and tilts under their boots. Long before anyone had radar or satellite weather, people still needed to move cargo past the bottom of South America. Cape Horn and the Drake Passage were the only real door. That is why this place became known as the Everest of seafaring. A tall ship could sail out of the Atlantic with full sails and high hopes, but still be driven back for weeks by strong headwinds and rough water, never making it around the Cape. Logs from the age of sail are full of the same slow horror. Men talk about seeing the same bit of coastline again after thinking they had escaped it days earlier. They write about scurvy swelling their gums and opening old scars. They tell stories of phantom lands that turn out to be clouds or waves. Wooden hulls creak and groan, and every strange noise sounds like the first crack of the ship breaking apart. Some of the ships that vanished here became legends. One of the most famous is the Spanish ship of the line San Telmo. It left Cadiz in 1819 as part of a fleet heading to reinforce Spanish rule in South America. Somewhere near Cape Horn, the San Telmo met heavy weather and was lost with more than 640 men on board. Wreckage that might be from the ship later washed up on Livingston Island in the South Shetlands, leading some historians to think her crew may have been among the first people ever to reach the Antarctic region, though they never lived to tell anyone. Decades later, in the Great Clipper era, shipbuilders tried to outrun the danger with speed. Champion of the Seas was one of the fastest sailing ships of its time, setting a record for the longest distance sailed in one day in the 1850s. But even that proud ship did not escape the Southern Ocean. She was badly damaged by storms on later voyages and ended her working life wrecked on rocks off Australia after being driven onto shore in bad weather. For a long time, people could tell themselves that this was just a problem for the old world. Wooden hulls, cloth sails, no engines, no weather forecast, no radio. Once steel, diesel power, and satellites arrived, it was easy to think that the Drake Passage had been tamed. Then modern stories started to look disturbingly like the old ones. In the late 1990s, the German cruise ship Bremen was crossing the Southern Ocean on an Antarctic voyage. The ship was built for these waters, with an experienced crew and modern equipment. In heavy seas, a single huge wave hit the side and smashed the windows on the bridge. Water poured over the controls and shorted out the electronics. For a while, the ship lost power and drifted sideways into the swell, the worst way to face those waves, while the crew struggled to restart the backup systems. On November 23, 2007, the small cruise ship Explorer was pushing through pack ice near the South Shetland Islands on another Antarctic trip. She struck submerged ice that tore a gash in her hull. Water flooded in faster than the pumps could handle it. Within hours, the ship sank in the icy waters linked to the Drake Passage route. Every person on board survived only because the sea was just calm enough for lifeboats to work and nearby vessels could rush to help. Even very recently, with even newer ships, the pattern has not gone away.
It felt like a rocket hit the ship. The entire ship kind of...
In late 2022, the cruise ship Viking Polaris was hit by a single, very large wave while sailing near the Drake Passage.
It's like, did we hit an iceberg? You know, it just was so sudden like that.
We heard it smash against our window, and a lot of water came out.
The impact broke reinforced windows, flooded cabins, and killed one passenger. The ship had to turn back to port. These ships are not tiny yachts. They are polar-rated vessels, with steel hulls, ice belts, trained crews, and up-to-date navigation gear. Yet one bad hit in this stretch of water can still wreck the plan and put lives at serious risk. Part of why it feels so unfair from the bridge is that the danger is not only on the surface. The Drake Passage is not a smooth bowl of water with a flat floor.
One of the world's biggest icebergs is stuck and spinning in an ocean vortex off of Antarctica.
Under the waves, it looks more like a broken set of mountain ranges and valleys. Geologists call this system the Scotia Arc, an underwater extension of the Andes that bends out from the tip of South America, runs under the sea, and then rises again around islands and ridges on the way toward Antarctica.
That I'm going to be talking about now is the Scotia Plate down here between the tip of South America and the tip of the Antarctic Peninsula. And this map, which...
Charts and detailed surveys show that in many parts of the passage, the seafloor drops to more than 11,000 feet deep, with some pockets reaching about 15,600 feet. But along the line of the Scotia Arc, There are also broad banks where the bottom rises sharply, like Birdwood Bank, which comes up to less than about 1,000 feet below the surface. From up on deck, you never see these hidden cliffs and steps, but you feel what they do to the sea. One moment, the swell may be long and regular. A few miles later, the same ship can be riding weird crossed waves that seem to come from several directions at once. Sailors have their own way of talking about the rough spots down here. They mention washing machine areas where the front of the ship jumps up and down while the back swings from side to side, and even big ships twist and shake. They describe places where the sea looks broken, with short, steep waves and random peaks that don't match the main direction of the wind. Many of these trouble zones sit over sharp drops and old underwater ridges on the seafloor. Add ice and floating debris to all of that, and this narrow gateway at the bottom of the map becomes even more dangerous. In summer, icebergs and chunks of sea ice drift into the passage. They look smooth on top, but many hide long underwater keels that reach tens of feet down. In rough water or bad light, radar can miss smaller pieces, and a ship can hit solid ice long before the crew sees it clearly. And all this happens in a place where waves can reach heights that look unreal anywhere else. Reports from research and cruise ships talk about storms with waves over 40 feet, and rare giant sets that climb towards 60 or even 65 feet. At that size, a wave isn't something you simply ride over. It's a moving wall with enough force to slam into a ship's bow like a slow, heavy hammer. And as bad as it looks from the deck, this is only the surface story. When scientists stepped back, looked at the whole Southern Ocean from space, and sent deep diving robots under those waves, they realized this gate is doing something even stranger. The Southern Ocean's rogue waves and hidden traps. For centuries, sailors told the same terrifying story. Out of nowhere, the sea would rise into a single towering wall of water, one wave, bigger than the rest, fast enough to hit a ship before anyone could react. For a long time, scientists said those stories were just exaggerations. That changed on New Year's Day in 1995. In the North Sea, an oil platform recorded a single wave rising suddenly out of a storm. It stood about 85 feet tall, more than twice the height of the waves around it. One moment, the sea looked rough but normal. The next, a massive wall of water surged past the sensors. That was the first solid proof that these giant surprise waves are real. After that, the evidence kept growing. Satellites and floating sensors started spotting more of these waves, far more often than anyone expected. And when researchers looked at where they showed up most, one place stood out again and again: the Southern Ocean, especially the waters around the Drake Passage. The reason is simple and brutal. Down here, waves can travel for thousands of miles without hitting land. They grow longer and stronger as they move, but the water itself does not always flow smoothly. In some places it moves fast, in others it slows down or pushes back. When a fast-moving wave hits water that is fighting against it, the front of the wave slows while the back keeps pushing. The wave bunches up, grows taller, and suddenly turns steep and dangerous, like traffic piling up on a highway. At the same time, waves are coming in from different directions. Most of the time, nothing special happens, but once in a while, several waves line up at the same spot. For a few seconds, all that energy stacks into one place. The sea pulls itself together into a single, towering wall. One moment, a ship is riding heavy storm waves. Next, a dark wall of water rises higher than anything around it, moving fast, leaving almost no time to react. If that wave slams into a ship, the force is extreme. Reports show that the impact can be strong enough to bend steel, smash windows on the bridge, and rip apart parts of the deck built to survive normal storms. That's why even modern ships, strong, heavy, well-designed, have been badly damaged in these waters. The shape of the ocean floor makes it worse. Under the Drake Passage, the bottom of the sea rises and drops sharply. These underwater shapes push water upward and sideways. Above them, the surface can turn chaotic. Waves hit from different directions at once, rise suddenly, then collapse without warning. Ships that sail the same route often run into the same dangerous patches again and again. Sometimes the bottom itself gives way. Surveys have found signs of huge underwater landslides in this region. When a slope collapses, it shoves massive amounts of water aside and sends a powerful wave racing outward. In open ocean, that wave spreads out. In a narrow passage, it can stay focused. A ship caught in its path may never know what caused the sudden impact, only that the sea rose and hit in a way no one expected. Even the ships themselves can make things worse. Modern cargo ships are long and wide, and they naturally roll side to side. In calm seas, that motion settles down. But in the Drake Passage, the spacing of the waves often matches the ship's natural rhythm. Each wave gives the roll another push. A small lean grows deeper. 10 degrees becomes 20, then 30. Cargo straps strain. Containers start to slide. Shipping groups estimate that hundreds of containers fall into the ocean every year, and in bad years, more than 1,000. Violent storms are a major reason, and many of those losses happen in places like the Southern Ocean. Once heavy cargo shifts to one side, a ship can tip past the point where it can recover. Even the sound of this place feels wrong. In the late 1990s, underwater microphones picked up a strange, deep noise from the Southern Ocean. It lasted about a minute and was powerful enough to be heard nearly 3,000 miles away. People nicknamed it the bloop. For a while, some joked about sea monsters. Later studies showed it was massive chunks of Antarctic ice breaking and scraping along the ocean floor. Ice breaking with enough force to send sound across an entire ocean. And that's only part of the noise. This region is full of deep, low sounds, waves crashing into each other, non-stop wind, grinding ice, and distant rumbling from the earth below. Much of it sits below what people can clearly hear, but the body still feels it. Studies show that this kind of deep sound can make people feel uneasy, anxious, or sick, even when they don't know why. Pressure in the chest, a sense that something is wrong. Now imagine standing on a steel ship in the Drake Passage for days, while the entire hull vibrates with that sound as storms hammer the sea. How this strip of sea shapes weather, wildlife, and trade. Down here, the wild water is not only trying to sink ships, it is also running one of the most important hidden systems on Earth. When cold storms slam this part of the Southern Ocean, they do something very simple but very powerful. They take surface water, whip it with wind, and chill it until it is heavy enough to sink. That heavy water slides down the continental slope around Antarctica and spreads out along the bottom of the ocean like a slow, cold river. Scientists call it deep bottom water, but in normal words, it is just very cold, very salty water that has sunk and now creeps along the seafloor for thousands of miles. While that water is at the surface, it is in direct contact with the air. Waves throw up spray, bubbles burst, and gas in the air gets mixed into the top layer of the sea. One of those gases is carbon dioxide. Cold water can hold more gas than warm water, so this storm belt soaks up a lot of carbon from the sky before that water drops down into the dark. Once it sinks, that water does not come back up for a very long time. We are talking hundreds of years for some of it. That means the Southern Ocean, including the zone around the Drake Passage, is not just rough water. It is one of the main places where the planet hides our extra carbon. Many studies say this band of ocean, which covers only a slice of the global sea, takes up a large share of all the carbon that the oceans remove from the air. In simple terms, it is one of the main brakes slowing down how fast the world heats up. Now picture what happens if that brake starts to slip. As Antarctica warms, more fresh water pours into the sea from melting ice and from extra rain and snow. Fresh water is lighter than salty water. When enough of it spreads across the surface, it makes the top layer less dense. Lighter surface water does not want to sink even if it is cold. That means the deep carbon river can weaken. The ocean still gets stirred, but less of that mixed, storm-beaten surface water ends up locked away in the deep. At the same time, stronger winds around Antarctica can start dragging old deep water back up. That deep water has been carrying carbon that was stored long ago. When it rises and reaches the surface, some of that carbon can leak back out into the air. The region shifts from acting like a sponge to acting more like a damp rag being wrung out. So this strip of ocean at the bottom of the map is not just a scary place for ships. It holds a quiet switch that affects whether the sea is hiding our carbon or slowly feeding it back into the sky. If that switch flips the wrong way, warming speeds up, ice melts faster, and the storms down here get even more intense. It is a feedback loop no one wants to trigger. The strange twist is that the same sharp edges in the ocean that drive this climate engine also cut life into separate worlds. Sail south through the Southern Ocean, and at some point the water temperature drops by only a few degrees. The salt content shifts a little. You cannot see the line from a ship, but the instruments do. This is the Antarctic convergence, also called the polar front. On one side, you have slightly warmer subantarctic water. On the other side, you have true Antarctic water close to the freezing point of the sea. The change sounds small, but for living things, it is huge. Many types of plankton, fish, and even bacteria live only on one side of that front. They almost never cross it. Over millions of years, Antarctica became surrounded by cold water, cut off by this moving ocean barrier. Life there evolved in unusual ways. One good example is the ice fish. Most fish use red blood packed with hemoglobin to carry oxygen. Some Antarctic ice fish have almost no hemoglobin at all. Their blood is so clear it looks like water. Instead of packing more pigment into their blood, they went the other way. Their bodies live in water that is loaded with oxygen because it is so cold and well mixed, so they can get by with pale blood in wide vessels. Many of them also carry special antifreeze proteins that stop ice crystals from growing in their blood and organs. Then there is Antarctic krill, a small shrimp-like creature that looks like nothing special at first glance. There are so many of them in the Southern Ocean that their total mass has been estimated at several 100 million tons, on the same order as the mass of all humans on the planet. Huge clouds of krill drift with the currents, feeding on tiny plants in the surface water. They are the basic fuel that runs much of the food chain down here. The same storms and currents that make life hard for ships help keep this food belt running. Winds shake nutrients loose from the deep and bring them up near the surface. Sunlight in summer does the rest, feeding blooms of microscopic plants. Krill eat those plants. Penguins, seals, fish, and whales eat the krill. Seabirds grab fish and squid that fattened up in these waters. The rough strip near the Drake Passage, which people see as a barrier, behaves like a huge, messy, but very effective food machine for the animals that can handle it. Some of those animals do not hide from the storms at all. They ride them. The wandering albatross is one of the best examples. Its wings can stretch to more than 10 feet from tip to tip. That span lets it pull off a trick called dynamic soaring, which is just a fancy way of saying it steals energy from the wind. The bird climbs up into fast air, turns, glides down into slower air, then climbs again. By repeating this pattern, it can travel for hours, even days, without much flapping. Some tagged birds have been tracked circling the Southern Ocean and crossing thousands of miles in only a few weeks. For an albatross, the howling wind that scares humans is a free engine. The rougher the Drake Passage, the more power flows into its wings. Whales use this region in a different way. Blue whales, fin whales, humpbacks, and others migrate into the Southern Ocean to feed on krill during the long Antarctic summer. A single blue whale can eat many tons of krill in a day. They need those rich patches to build and store enough fat to survive long trips north to breed. But even these giants have to fight through noise and motion down here. Storms and big seas fill the water with constant low-frequency sound. At the same time, modern shipping adds its own hum. Some studies show that whales in noisy oceans shift the pitch of their calls or sing less often when the background roar gets too loud. In a strip like the Drake Passage, where wind and waves are almost never quiet, whales may have to change how and when they talk just to keep track of each other and to find mates and food. While animals are still adapting to this place, humans have mostly tried to dodge it. That is how the Panama Canal was born. Before the canal opened, a ship traveling from New York to San Francisco had two options: sail all the way around the bottom of South America or unload its cargo. move it across land by train, and load it onto another ship. The sea route around Cape Horn and the Drake region was roughly 13,000 miles. The canal cut that to about 5,200 miles. That is a massive shortcut in both distance and time. When the Panama Canal opened in 1914, it changed world trade. Ships could now avoid the southern tip almost every time. Fewer captains had to bet their lives against the storms and strange water at the bottom of the map. But canals depend on rain and lakes, and those can fail. In 2023, Panama went through one of its driest years on record. Water levels in Gatun Lake, which feeds the locks, dropped so much that the Canal Authority had to cut how many large ships it could take each day and how deep those ships could sit in the water. At one point, daily transits fell well below the normal average of more than 30 ships per day. Queues stretched past 100 vessels, and some ships waited close to 3 weeks for a slot. Auction prices for a fast-track passage went over several $1 million for a single ship. When delays happen, owners rethink their routes. Some ships go around South America or Africa instead of waiting. For the largest ships, the long way was always the only way. On top of cargo ships, there is now a whole other crowd choosing to face this strip of ocean: tourists. Antarctic travel has gone from a rare thing for scientists and a few rich explorers to a booming business. In the late 1990s, only a few thousand visitors a year headed south by ship. In recent seasons, industry groups have reported total visitor counts over 100,000 in a single year, most of them crossing the Drake Passage at least twice on large expedition vessels. Many of these trips are sold as once-in-a-lifetime adventures, with the rough crossing itself treated as a badge of honor. People post clips of dining rooms tilting and brag about walking down hallways that feel like a moving treadmill. But behind the fun videos, the basic risk has not changed. A modern cruise ship may have strong steel, radar, and good weather forecasts, but if something goes wrong in the middle of a real Drake storm, help is far away. Helicopters can't reach them safely. In giant waves, lifeboats slam against the hull like hammers. For a long time, people liked to think that the waters near Antarctica were clean and untouched. Recent studies have shown the opposite. Tiny pieces of plastic, called microplastics, have been found in Antarctic snow, in sea ice, and in the surface waters of the Southern Ocean. Some work has even shown that Antarctic krill can swallow plastic fragments and grind them into even smaller bits inside their guts before passing them on. That means plastic from faraway cities and rivers is now being pulled into the same food web that feeds penguins, seals, and whales. Thanks for watching. Now check out the videos popping up on screen for more unbelievable stories.